Okay, now we're going to discuss thyroid hormone synthesis and utilization. So this process takes place in the thyroid, and what happens is we have sodium and iodide come into our thyroid through the blood, and they come into the follicular cell of our thyroid through the NIS symporter, or otherwise known as the sodium iodide symporter. So this iodide is going to be transferred to the pendrin antiporter, which brings iodide from our follicular cell to our colloid cell. And during this process, it's also going to bring chloride out into the follicular cell from the colloid. And once the iodide gets into the colloid cell, it's going to be oxidized by TPO and become iodine. After this happens, the enzyme thyroglobulin is going to be exocytosed into the colloid cell, where it will meet iodine and create MIT and DIT. This is going to go back into the follicular cell and become T3 or T4. And these hormones are going to go back to the blood and ride on the thyrobinding globulin and then transfer into the blood to other target tissues. One example of these target tissues is the brain. So what happens is this T3 is going to come from our blood and go onto a receptor of our brain. And here when it attaches, it is going to cause a lot of great things like energy production, catecholamine production, which are like our happy hormones, and then serotonin production and uptake. But unfortunately, if a patient has any type of metabolic inflexibility or something of that sort, they are going to release a hormone called RT3. Which is called reverse T3. When reverse T3 attaches to the receptors of the brain, it's going to cut out all of these functions, which can cause things like depression and anxiety.